Right, as I promised, I told you I would break the video for Geometry A Unit 4 Lesson 3 into two parts. And so that's what we're doing here. In this particular example, we're dealing with an equation that has a radical. So y equals the square root of 16 minus quantity x minus 2 squared minus 3. This actually is the equation of a circle. It's not really the equation of a complete circle. Let me demonstrate real quick. If I were to bring up Desmos, don't have it open here, so desmos.com/calculator. It's a good graphing calculator. I highly recommend. And insert this equation, y equals square root sqrt 16 minus parentheses x minus 2 quantity squared minus 3. It would be a semicircle, a half circle, and that's because the square root symbol actually means only the positive root of. And you're only going to get the top half of the circle out of this equation. So that's one oversight, I think, in the lesson. It's not a full circle, it's only a half circle. And that has to do with the fact that graphing calculators they only work with functions. Functions require a unique output for every unique input, for every input. But we'll not get too deep into that. Well, I want you to notice a couple of things about this circle. This circle has a center at 2, -3. And I want you to notice where those numbers are, -3. I want you to notice where those numbers are in the formula. 2. There's a 2 right here. That 2 is is the x-coordinate of the center. But notice it's x minus 2. You might think that would go left, but one of the rules we learn of when we do what's called transformations on functions is that x is oppositesville. Whatever you do to x, it does the opposite of what you think. So if you subtract 2 from x, it's actually going to move it to the right 2. Now, -3, the -3, is the y-coordinate, and that moves it down. If I put in -1, it would go down 1, -2, down 2, -3, down 3. Okay. Same thing here for the horizontal. You can change this number. If I move it right 3, right 4, and put it back on 2 here. If I changed it to a 1, it would move left. Okay. So you can read the center of the circle from there. The lesson had you complete what's called a t-table. They had you pick some values of x, right, and plug in those values. Now let me do just one quick example here. Let's say I picked x and I'm going to put in 2. So then y would be the square root of 16 minus 2 minus 2 squared, square root, minus 3. And work that out. 2 minus 2 is 0. 0 squared is 0. Don't forget the square root. 16 minus 0 is 16. Square root of 16 is 4. 4 minus 3 is 1. Okay, so working it out. And so this corresponds to the point 2, 1. So 2, 1. Okay. We already know that the center is at 2, -3 right here. So let me try one more value here. Let's do 5. Yeah, let's put in 5. So 16 minus 2 minus 5 squared, square root, and this isn't going to come out nice. 2 minus 5 is -3. -3 squared is 9. 16 minus 9 minus. Try that again. 16 minus 9 is 7. Square root 7 minus 3, and for that we got to reach for a calculator. I'll go to Desmos here. Square root 7 minus 3. got to get out of the square root of 7 minus 3. I get negative 0.35. Okay, so 5, so 2, 4, 5, negative 0.35, right about here. And you'll note that if I draw a circle centered at 2, negative 3, it goes through those points. But remember, it's technically not a complete circle, it's only a semicircle, though the lesson treats it like a full circle. To get the full circle, here's what I'd have to do. I would have to re-enter the equation, but put a negative sign in front of the square root. Negative square root, 16 minus x minus 2 squared, all minus 3. And now you get the rest of the circle. You get the bottom half. Okay, because square root means only the positive root of. And technically, there are 2 roots to any whole number, any positive number. All right. Now, that said, we've got all this information here, but what we're after here is what happens when we translate or move. And so we can apply translations to all of this just like we do to polygons. And I think that was the point of including this as an example. Let's say we want to move. Whoops. I did this on top of the original. Oh well. I was supposed to use a separate slide so that it didn't mess up the drawing here. But now I'm stuck with it. All right. Okay, delete. Delete. I'll delete as best I can. All right, that's acceptable. That's acceptable. Okay, what if we wanted to translate by the rule? By the rule x1, whoops. So x1 plus 4 equals x2, and y1 minus 3 equals y2. That would be the equation method that we talked about before of expressing it. Or we could express it as a function, f of x equals x plus 4, g of x equals, or g of y equals y plus or minus 3. That would be the function notation. Then from earlier, vector, positive 4, negative 3. Or description, right 4 and down 3. So 4 different ways to represent this transformation. Where would the center be? Well, the center would be 4 to the right, 1, 2, 3, 4, and 3 down. Or 3 up. No, 4 right, 3 down. Okay, 1, 2, 3, 4, 1, 2, 3. There's the center, and we can do that for these other points. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. Okay, now where this was a nice point here, this is 2, 4, 6, negative 2. This one is not very nice. It's 2, 4, 6, 8, 9, negative 3 point something. And the question is, point what? You may recall, I think I got rid of it already here. What was it? It was square root 7 minus 3. Square root 7 minus 3. Negative 0.35. So this is negative 0.35. So what I do here is I take the y value, negative 0.35, and I subtract 3 to get negative 3.35. 3.35. Okay? And we get a circle here in the correct place. Same diameter here. and it gets moved down here. Okay. An interesting question that I might pose after this is, can you rewrite the equation of the new circle? But that goes beyond the scope of the lesson. All right. So just remember the 4 ways of representing transformations. Equation, x1 plus something equals x2. y1 plus something or minus something equals y2. Function, f of x equals x plus h. G of y equals y plus k. Vector in pointy brackets, where the first number is the number right and the second number is the number down. And verbal description, right 4 and down 3. And really, that's what this lesson is about, in my opinion.